Let's take a look at this example. We have simply 3 resistors connected in parallel. Okay, if you don't see that, simply notice that the positive terminal of your power supply is connected to each resistor, okay, at the top. So 1, 2, 3 connections, right? And the negative terminal is connected to each resistor at the bottom, right? So it makes these 3 components, okay, connected in parallel. Also, please notice that we have 2 ammeters connected in the circuit. And what is very important, that you have to remember that ammeter must be connected in series in the circuit. Okay, you cannot connect ammeter in parallel. Okay, ammeter must be connected always in series with the circuit or with the single component. So see, current is going to flow by the resistor R3, will go to the ammeter, and from ammeter we'll get back to the circuit. The same story is going to happen over here. We have total current flowing through the ammeter, and from ammeter we'll get back to the voltage source. Okay, so ammeters are connected in series always, okay? Many students burn the fuses in the ammeters because they connect ammeter directly across the component, which is wrong. Now, for the given network, we have to determine all currents. So if these resistors are connected in parallel, so they are connected directly across the voltage source. So if I want to find, let's say, R1, simply divide VR1 over R1, okay? And VR1 is equal 12 volts, okay? Remember that in the parallel circuit, the voltages across each components are the same. So V1 is equal VR1, this is also equal to VR2, and this is also equal to VR3, and this is equal 12 volts. Okay, so VR1 is equal 12 divided by 4 kilo ohms. This is equal 3 milliamps. Okay, for those of you who have difficulties to see that, simply use the calculator. So I have 12 divided by 4 exponent 3. This is equal 3 milliamps. Because we have 3 resistors and all of them have the same resistance, so the currents are going to be the same. So IR2 is also equal 3 milliamps, and IR3 is also equal 3 milliamps. Okay, so we can find also I total. I total I'm going to find by using the KCL, Kirchhoff current law. So IR1 plus IR2 plus IR3, which is equal 3 milliamps plus 3 milliamps plus 3 milliamps is equal 9 milliamps. Okay, and these are the solutions to my problem.